Hi guys, my name is Mark Johnston and I do STEM education. In today's video, I'm going to show you how you can take the line detector activity from VEX VR and we can move it into the real world using VEX Go. So without any further ado, let's get into it. All right, here we are at vr.vex.com, and we're going to start in the virtual environment. Great thing about virtual is that it's a clean environment and it will always behave in a very consistent way. I'll click on Playground. So to get here, you go to vr.vex.com, and then I clicked Playground, and I was already using the line detector, so that's why it's already showing line detector. But if you need to, you can click the little drop down and find line detector. Then you can click this little location button, and we want to move our robot to location B. Now the task is real simple. I want the robot to count the number of black lines. But in order to do that, I first need it to drive forward and stop when it hits this back wall. So let's just do that real quick. I'll go to Control. And I'm going to say repeat until the bumper is pressed. All right. So I'm going to just say drive forward. And I'm going to repeat that driving forward until the bumper is pressed. So I'll go to sensing. And then it doesn't matter if I say left or right bumper. Either one is fine. And then I'll say stop driving. So that's a real simple program to just get the robot to drive across and stop. Now I could just click play right now and just test that, but I want to do one more thing. I don't want to waste him driving across the whole field for nothing. I want to open up this monitor right here. It's this button and it looks like a speedometer. I'm going to open that up and there's some information I can watch in there while the robot is going. But I just need to tell it what information I want to watch. So go back over here to the toolbox and click on this little turquoise bluish color for sensing. And then I'm going to scroll down a little bit and select the brightness and percentage. Now notice it says front eye. There's a front eye and a down eye, and it's going to look at both of those for me. So I can watch those values change as the robot drives. I'll go ahead and click play, but keep an eye on that down eye brightness in percentage. It's 100, 0, 0, 0. So each time it hits that black line, it goes down to 0. Perfect. That's what I needed to know. So if I wanted to count the number of lines, then I'm going to store that information in a variable. So I'll go to variables, and I already have a variable called my variable, but that's not very descriptive. So I'll right click on it and say rename variable, and I'm going to rename it to num_lines like that. And then I'll say, I'm going to watch that one also. So I'll click the little checkbox so I can watch the value. Now, if I drive forward, I can't just count. I can't just say change the number of lines. I need something to happen, right? So I'm going to say if. And so I'll go to control and say if and put an if right after the forward. So drive forward until the button is pressed. But while you're doing that, if what? If the brightness value, let's find the brightness value. Here we go. This guy right here. And notice I use this area to like work in. Okay, you can click and drag stuff over here. You can have it in the area and work on it before you place it where it needs to go. Okay. So if the down eye brightness in percentage is less than 100, so I get those less than, it's in the operators. Those are the green ones. So I need a less than. And now this one I can put in there. So if brightness in percentage is less than 100, then I'm going to add 1 to my variable. And now I've intentionally not finished this. I want you to see what happens if I leave it this way. I'll reset and play. Watch the variable value. Whoa, 7, 13, 21. It's adding really fast. The whole time it's seeing that black line, it's adding 1, adding 1, adding 1. So what we need it to do is to just add 1 and then chill for a minute, okay? So what I'm going to do is use a drive forward. And so after it sees that black line and then it adds 1, I'm going to have it drive forward for, say, 100 millimeters. Now I'll reset and try again. And sure enough, there we go. So as long as those black lines aren't closer than 100 millimeters, this program works just fine. All right, I've recorded all 5 lines. Great. Now, I want to do this with a real robot. So how can we do that? Well, we go to codego.vex.com, codego.vex.com. And here we go. It looks very, very similar. All right. But we're going to be programming a physical robot. So we're going to need a physical robot, right? Well, it just so happens that I have a physical robot. All right. Let me show you where I found the instructions to build this and all of that good stuff. All right. If you are at codego.vex.com, you can click this button that says Builds. Builds will open up another tab, and there's a lot of different items that you can choose from that you can build with your VEX Go kit. Pretty versatile for basically $150, right? And you can build all these different things with a VEX kit or a VEX Go kit. All right, so I built the code base, and then I went ahead and put a down eye on the code base. And then I went ahead and put a bumper on the front, all right, because I'm crazy like that. All right, so notice that it's basically the code base. I put the eye on it, and then I added this whole thing right here with the bumper and everything. All right, so that way I have a bumper. All right, now we're back at codego.vex.com, and we need to connect our robot. So on the robot itself, I'll push the button to turn it on. Then I'll click Brain up here in the upper right on the browser. I'll click Connect. And it depends upon the browser that you have, but this is what it looks like in Chrome. So I'll select VEX Go, click Pair, and notice that the green light is now flashing. It's going to check the firmware, make sure everything's okay there. And it's good. And so now I'm ready to code with my robot, right? So I think, well, let's just do something simple. Let's wait. I can't get it to drive. Where are the drive commands? Well, remember you can build all those different kinds of things with Go. And so in VR, there's just one robot. So that all the commands are already there, that those are the commands you can do. With Go, you need to configure the robot, but it's real easy. There's a devices button right here in the upper right, and then I'll click Add a device. The code base is what I'm using, but you might have built the robot arm or the supercar Or you may have come up with your own creation and you want to specify what sensors are in what ports and what motors are in what ports. So I'll select code base because that's what I built. And it tells me that my right motor should be in port 1. And this is a good time I can check to make sure my robot matches what this is. LED bumper is in port 2. I did put that there. Electromagnet, I'm not going to use it. It's not connected, so this shouldn't hurt me. And then left motor is in port 4. And then, of course, the I is in the I port. Okay, click done. And then, boom, look at that. Now I have those commands that I was looking for. I'm just going to make him drive forward and then drive reverse for the same amount, just so that I can make sure everything's working okay. So I'll click play. Hey, forward and backward. All right, great. So now I'm ready to go ahead and do what I did in VR. I have a repeat until the bumper is pressed. So I'll go back over here to go. Under control, notice I have a repeat until. And then under sensing, I have bumper pressed. And then I'm going to say drive forward. When the bumper's pressed, I'll stop driving. All right. And let's go ahead and test that out. I'll push stop. And let's push play. See what happens. Here he goes. And boom, stop. Nice. All right. Check this out. We got another tab here called the Drive tab. I'm a little lazy. I don't want to get out of my chair and go get it. So I'm going to click the Drive tab. It says reconfiguring for a second. This is set up for if you're like using a tablet over here on over this shoulder, that button right there, and the button over there. Those are like for your thumbs for tank control. So if you click on arcade, it switches over to 1. And then, of course, you can use your mouse or even just your finger if you are on a tablet, if you want to just use 1. And so now I can actually control the robot from the browser. Don't hit the camera. Just like that. All right. So now he's ready for the next run. I'll click on code again. Just like I did in VR, I want to watch some values. I want to see what the sensors are seeing. So I'm going to go to sensing and scroll down and see eye brightness in %. There it is. Right now it's showing 2. Interesting. And let's see. There is one other thing I need to tell you about with a physical robot. Okay, the physical robot is, you can set the eye light power. All right, so the eye light power. Look underneath, and you see the eye, and you see that there's a light. And that's how it works. There's a light on, and the light is shining down, and then what is reflected back into the eye is how it's getting its brightness percentage values. If, for instance, the lights in the room were off, it wouldn't be able to see anything. It would need something to shine and reflect back to be able to tell if, you know, the brightness of the thing that's underneath of it, right? And so in the real world, you know, the light changes. You could be in a very bright room. You could be in a very dark room. It could be in a classroom where it's in the morning and the light is shining through the window. Or in the afternoon, and the light is not shining. And so it can change even throughout the day. And so the light power, you might need to play with that a little bit to get it to give you more consistent values. Okay. Now in my office, I've done this a few times and I've had it run across it and I've looked at it and I found that about 40% power gives me the most consistent reading from that sensor. So I'll go ahead and click play again and I'm going to watch these values change now. So play. And notice it changes as it goes. Now, it's a little too fast for me. So I'm going to make the robot drive a little bit slower. So we're going to go to drivetrain and then set drive velocity to 30%. All right, let me get that little sucker to come back over here. Just like this. That's so much fun. All right. Here we go. Back to the code. And so it's going to go a lot slower now. And this time I'll go ahead and have it record the information. Let's go back to VR real quick and look at what we did. We had an if. We had an if the percentage was less than 100%. Okay, so let's go to control and we'll say if, and then get an operator, less than, and then we want sensing, we want brightness in percentage. If brightness in percentage is less than 100, we need a variable. We'll right click on the variable and rename it to numLines. Like that, and submit. And change the value of numLines by 1. Let's look at our VR program again. And we have it drive forward for 100 millimeters. Now, I know that 100 millimeters on my desk is going to be way too far. So I'm going to do 20 millimeters. All right. Now, at this point, I have the brightness of the eye turned up correctly. It's going to drive at about 30% speed. It's going to drive all the way until the bumper is pressed. When the eye sees less than 100%, it's going to change the value of numLines by 1. And then it's going to drive forward for 20 millimeters and then continue again through this repeat until that button is pressed. Oh, let's watch it and cross your fingers. Here we go. It got 1, 2, 3. Hey, and that's it. Look at what we did. We took a VR program that worked and that would allow us to count the number of lines. And then here in my office, I taped some construction paper to my desk. I built this little Go robot, then went to gocode.vex.com and basically put in the same program. I had to do a little bit of troubleshooting for the real world part of it. But the great part of this is that I can take VR as a clean environment to practice what I'm doing, know that my program works in that environment, and then take it into the real world. And if something doesn't quite work right, I can troubleshoot it. But at least I know that the idea behind my program is working because it works in VR. Well, thanks so much for watching. I really do appreciate it. If you're not subscribed, feel free to click that subscribe button. If you liked it, give me a like. And of course, put some comments down below. Let me know what you think or if you have any questions. Thank you so much, and I will see you guys in the next one.